The first question asks us to take a look at the equation for calculating the partial charge on fluoride and the hydrogen fluoride molecule. Although the work is all done here for us, the task in this case is to figure out what the 7, the 6, and the 2 mean and how we could get these numbers if we had to do this again later for another molecule. My start point here is my Lewis structure for hydrogen fluoride. Instead of the bond, I've drawn the bonding electrons just as a pair of electrons between the hydrogen and the fluorine. If I look at this Lewis structure, I notice that the electrons split into two groups. 6 of the electrons we see here are unshared pairs of electrons, and 2 of the electrons we see here are involved in a bond. And that's the obvious of the two numbers in this equation. 6 represents the number of unshared electrons on fluoride, and 2 represents the number of shared electrons in the hydrogen fluoride molecule. Fluoride is going to get credit for 6 electrons 100% of the time because these 6 electrons belong only to the fluorine atom, and these shared electrons in between the hydrogen and the fluorine end up with the fluorine 63.7% of the time, so fluorine is going to get credit for 63.7% of the 2 shared electrons, or the equivalent of 1.27 electrons. The last of the numbers we have to worry about is the 7. Remembering our periodic table and looking at the periodic table, you notice immediately that fluorine is in the 7th column of the periodic table. And that's what the 7 represents. It's best probably to think about this 7 as representing the core charge for fluorine. And then the negative signs start to make sense. If we think of the 7 as a positive 7 core charge, the unshared electrons counteract 6 of that, so we take away 6, and now we're down to a total of positive 1 charge, and the shared electrons that fluorine has 63.7% of the time take away another 1.27 from the core charge, reducing the overall charge of fluorine to a negative 0.27.